Good afternoon, everyone, and welcome to our live coverage of the latest mission from Vandenberg Space Force Base in Southern California. Emma Robinson Smith will be performing the commentary duties for today's mission launch, a flight on behalf of U.S. Space Systems Command, part of the U.S. Space Force. Currently T-minus 27 minutes, 3 seconds and counting to the liftoff of a mission known as USSF, or United States Space Force 62, on board a special weather satellite designed to take over for a program that has been relaying weather capabilities back for the United States and its allies since the 1960s. SpaceX is currently targeting a T0 liftoff time of the Falcon 9 from Vandenberg at 7:25 a.m. Pacific. That's 10:25 a.m. Eastern, 14:25 UTC for our friends joining from around the world. Our editor, Stephen Young, helped with the technical aspects of the broadcast as far as getting set up this morning, but due to some scheduling, got a Will Robinson Smith solo show here. So bear with me if we run into some technical snafus, but we will do our level best here to guide you on a smooth path towards the launch of the Falcon 9 rocket, coming up in 25 minutes, 18 seconds and counting. So far, SpaceX says weather is good out in Vandenberg, 95% favorable for a Falcon 9 launch today. We are currently T-minus 21 minutes, 51 seconds and counting. Part of the way through the SpaceX fueling of the Falcon 9 rocket. We'll go through our timeline of the events that we're expecting so far. But as we get going, I want to thank the more than 2,200 of you that are joining with us live. Really appreciate that. If you could, be sure to give this video a like to allow more folks to find this live launch coverage as we continue to step through the count, bring you views of the Falcon 9 rocket in the next few minutes here. We are also powered by a wonderful channel member community here on YouTube. So our thanks to folks like SG, Renee, Sarah, Distributor 69, Jean, Jean-Marquis, Jimbo Indy, and many others for supporting us with channel membership, which includes a number of perks, including discounts at our online shop, shop.spaceflightnow.com, access to member-only videos here on YouTube, and of course, the ability to watch all of our Cape-based live coverage in 4K. Special shout to our wonderful moderators as well. I see Stephanie B joining us this morning. And thanks to our other mods, Astro Joe, and others. Really appreciate what you do for us in the live chat. Last but not least, you can follow SG's lead by using the YouTube Super Chat feature. If you have a comment or question about this mission and it's appropriate to be read on the show, we'd love to bring you into the conversation by using a Super Chat feature. We'll also try to keep an eye out on the live chat for member comments as well. T-minus 19 minutes, 53 seconds and counting. Just a little past the point where the big vent would occur as the feed lines are being chilled prior to second stage LOX load. So let's go ahead and step through the countdown, let you know the milestones that are still ahead of us here for this Vandenberg flight. At this point, SpaceX will have given the go-ahead for the start of propellant load. That happened in T-minus 38 minutes. Prop load begins with the loading of rocket-grade kerosene, or RP-1, on board the first and the second stages of the Falcon 9 rocket. At the same time, liquid oxygen is loaded on board the first stage. At the T-minus 30-minute mark, cryogenic helium is loaded onto the pressure vessels of the first stage. That same process happens at about T-minus 26 minutes for the second stage. T-minus 23-minute mark. Loading of second stage kerosene wraps up. That's followed by the big vent at about T-minus 20 minutes, 50 seconds that I just mentioned. And then at T-minus 16 minutes, which will be the next event that we're looking for here, that's when the second stage liquid oxygen load begins. And at T-minus 7 minutes, that's when the chill down of the 9 Merlin engines gets underway. It involves flowing a small amount of liquid oxygen through the plumbing and turbo pumps, helps protect the engines from the risk of thermal shock and damage during the startup sequence. About 6 minutes before liftoff, the first stage kerosene tank should be full. And at T-minus 4.5 minutes, the strongback retract sequence begins. It starts with the clamp arms underneath the payload fairings opening up, and then the transporter erector, or the strongback, reclines about 13 degrees away from the Falcon 9. A little bit different here in Vandenberg as compared to the Cape base launches either at KSC or Cape Canaveral Space Force Station. 3 minutes out, the first stage liquid oxygen load should be complete. It's followed at the 2-minute mark with second stage liquid oxygen loading wrapping up. At that point, the Falcon 9 rocket is fully fueled with 1 million pounds of propellant. In the final 60 seconds, control of the countdown is handed over from the ground sequencer to the Falcon 9's onboard flight computers. The propellant tanks are brought up to flight pressure. The launch director will give their go for liftoff 45 seconds out. That's followed by the engine ignition command being issued at T-minus 3 seconds. And if all 9 engines ignite and are healthy, the flight computer will give the command for the hold down clamps to release the Falcon 9 for T0 liftoff, which is currently targeting 7:25 a.m. Pacific, 10:25 a.m. Eastern, 14:25 UTC. Or put another way, 16 minutes and 24 seconds. As second stage liquid oxygen load is about to begin, let's go ahead and briefly step through the trajectory for today's mission. The spacecraft on board the weather system follow-along microwave spacecraft. Falcon 9 will be heading into a sun-synchronous orbit, so we'll lift off from Space Launch Complex 4 East from Vandenberg Space Force Base. That red line you see indicates that this is going to be an RTLS operation, or return to landing site, which means that the first stage booster flying for a third time, tail number 1062, or excuse me, B1082 in the SpaceX fleet, will be returning for a land landing as opposed to heading out to the drone ship. Give you an idea of what the spacecraft looks like. This is a rendering of this on orbit. This is the first of 2 planned launches of this spacecraft. The first, of course, launching today. The second, preparing to launch not until about 2028. It's replacing, as I mentioned, a series of satellites that harken back to the 1960s. This is an artist's depiction of what those spacecraft looked like. It was part of the Defense Meteorological Satellite Program, or DMPS, which first launched back in 1962 and were under the purview of the National Reconnaissance Office. The program was declassified in 1972, allowing for the data to be used on a wider front. However, the program experienced a number of issues in its latter years. A decommissioned satellite that launched back in 1991, retired in 1995, broke up in 2004 and created dozens of pieces of orbital debris. And then in 2015, there was a faulty battery on the F-13 satellite, which also disintegrated, resulting in about 147 pieces of debris. And it was in 2015 when Congress ordered the end of the program and halted the launch of the most recent satellite in that fleet at that point, F-20, scrapped the program. There was another issue back in 2016 with the F-19 satellite. And that led us to the development of this spacecraft, which you see here. The weather system follow-on microwave spacecraft. It's developed by Ball Aerospace, which is now a company owned by BAE Systems. You could see it going through its final testing in Colorado before it was brought over to Vandenberg Space Force Base, where it was integrated in Falcon 9 payload fairings. This is also notable because this is the first time that a national security space launch mission is going to feature flight-used payload fairings. You can see the mission patch design for the WSF-M satellite. We are getting views from SpaceX, so let's go ahead and take a look here at the Falcon 9 rocket, standing ready for a morning liftoff with some nice low fog in the area but fortunately not enough to obscure our views of the Falcon 9 rocket. Certainly appreciate the 5,500 of you that are joining us live. If you're just hopping in, you're watching our live launch coverage of the WSF-M satellite. Again, this is an image of the satellite that we just showed you before it was encapsulated into the payload fairings. And as noted by SpaceX, these fairing halves will be flying for a second time. And they'll be scooped up out of the Pacific Ocean after they splash down into parachutes by the West Coast Recovery Vessel Go Beyond. Let's listen in for a status update from SpaceX.
T-minus 11 minutes and 30 seconds, the SpaceX team continues to count down towards our 37th launch of the year. I'm John Innsbrucker, and I'm the Falcon Principal Integration Engineer at SpaceX, excited to be joining you today. Now, currently, the good news is all systems are go. At T-minus 38 minutes, the SpaceX launch director conducted the electronic poll of the launch team. We got the go for both prop loading and launch. Now, we're currently loading both RP-1 kerosene and liquid oxygen propellants onto the Falcon 9 first stage booster. And we've already completed loading of kerosene onto the second stage. We're now down to just loading liquid oxygen onto stage 2. Meanwhile, the TTEB ignition fluid that we use to light the Merlin engines, that's already on board. It's stored in small canisters that we installed while preparing the stages for launch. On top of the Falcon 9 is the spacecraft. Payload team reports they're ready for launch. So overall, we're tracking no issues on the rocket. Spacecraft's ready to go. And as you can see from the weather on the screen, we started with better than 90% chance of good weather, and we've remained good during the countdown. And of course, the range, they have declared they are ready to support a T0 of 7:25 a.m. Pacific Daylight Saving Time. Now, if for some reason we do not launch today, we do have a backup opportunity tomorrow at the same time. But everything's looking good right now. With that, let's head back to Atticus to learn more about today's mission.
And a good update from John Innsbrucker about the health of the Falcon 9 rocket and the status of the mission. We're now T-minus 9 minutes, 12 seconds and counting in real time. 9 minutes, 42 seconds on the SpaceX feed. So if you are watching in Southern California, you're going to want to pay attention to our T0 time, as this is in real time. SpaceX coming in on a slight delay. So that's the time you want to pay attention for if you want to be able to see the Falcon fly with your own eyes. And given where the sun is right now, should be a pretty spectacular liftoff for folks in the area. What you're seeing here is just a promotional video from Space Systems Command about some of the capabilities of the spacecraft. Let's go ahead and pop away from this for just a moment. We'll come back when we've got views of the rocket again, but let's talk about the launch timeline and the points that we're going to be looking for once the Falcon 9 rocket lifts off. Just about a minute, 12 seconds after liftoff, the Falcon 9 will pass through maximum aerodynamic pressure, or Max-Q. That'll be followed at T+2 minutes, 19 seconds with a couple of events in rapid succession. First will be first stage minute cutoff, or MECO. That's followed by stage separation. A second stage engine ignition. That's when the Merlin vacuum engine will ignite on the Falcon 9 second stage. Then the boost back burn will begin, lasting a total of about 54 seconds, as the booster tail number B1082 will flip around and reorient itself for a return to landing site landing over at landing zone 1. A little over 3 minutes, the payload fairings will jettison, exposing the satellite to the vacuum of space for the first time. Then just a little bit after the 6-minute mark, the first stage entry burn will begin, lasting about 18 seconds. T+7 minutes, 24 seconds, the first stage landing burn will begin. setting up for typo there. It'll return for landing at landing zone 4 over at Vandenberg Space Force Base, about 7 minutes 52 seconds into flight. Then at T plus 8 minutes 27 seconds, the second stage engine will cut off. We'll go into a coast phase until T plus 49 minutes 51 seconds, when the second stage engine, or the Merlin vacuum engine, will reignite for a 5-second burn, setting up for the deployment of the WSF-M satellite at T plus 54 minutes and 57 seconds. As we heard from John, so far things are tracking well with the mission, and certainly appreciate the 9,300 of you that are joining with us live. If you haven't already, be sure to hit the like button, share the stream, allow some more folks to find their way in, as we're just a little over 6 minutes away from launch today, about a minute into the engine chill down sequence on the Falcon 9 first stage at this point in the mission.
Counting. All systems are currently a go for an on-time liftoff. Now, while we were watching the video, a couple of important steps have been completed. We heard the spacecraft team declare they had gone on internal power. That happened just a couple of minutes ago. Also, we have just completed fueling of the Falcon 9 first stage. That gets all the kerosene on board. So we're still loading liquid oxygen on both the first and second stages. Now, the next event coming up is going to be the retract of the strongback away from the rocket. The strongback you can see on the right side of the Falcon 9, that's the structure that carries the air conditioning up to the spacecraft, the stages, the electrical signals, the pressurization gases, as well as the propellant up to the second stage, and of course that air conditioning into the payload fairing you can see at the very top of the stack. Now, in preparation for retraction, the clamp arms that you can see are on the very top of the second stage, just below the payload fairing. They'll open up. They're hydraulically operated.
Tanks are pressurizing for strongback retract.
And you've heard that call out. We're pressurizing the tanks. We're putting a little bit of gas, kind of stiffens the tanks up, and that way the clamp arms open up with a nice rigid structure for the Falcon 9 underneath them. Now, once those arms are open, we then begin to recline the strongback away from the Falcon 9. That's a process.
Retract has started.
It'll take a moment. We've heard the call out. The process is now underway. And you can see the clamp arms around stage 2 are coming open. Coming up on T-minus 4 minutes, everything continues to be go. We're currently chilling in the Merlin engines. At T-minus 7 minutes, we open up the pre-valves, which allow the propellant down to the engines to get them prepared for the ignition just before T0. You can see the strongback is now retracting away. It's a slow process. We have hydraulic actuators at the base of the strongback that will pull it away. We do this slowly because you might be able to see we still have the lines that are carrying liquid oxygen to the second stage, as well as the electrical signals and the air conditioning up in the payload fairing. We need to make sure that all of those easily stretch out and all the mechanisms work so that we can get all the way back to the 77-degree position without tugging on any of the lines. Continuing to look good. You may notice a difference here at Vandenberg.
Launch load is complete.
T-minus 3 minutes. We've got the call out right on time. Liquid oxygen loading of the first stage is complete. We're now waiting for second stage. That'll finish up at just inside the T-minus 2 minute mark. I started to mention the strongback is different at Vandenberg. It's a different style. Cape Canaveral, for example, at Kennedy Space Center, we only recline a couple of degrees. Here we recline to 77 degrees and then pull away at liftoff. Now currently we're inside 2.5 minutes. The range continues to be green. And the weather, of course, as you can see there, has cooperated. Even the Vandenberg fog has stayed away. We don't expect any weather conditions to develop in the last couple of minutes. Again, if for some reason we do not launch today, we do have a backup opportunity tomorrow at the same time. We're listening in right now for LOX load closeout on the second stage.
So far, all good call-outs from SpaceX. About a minute 20 away from liftoff in real time.
Stage 2 LOX load is complete.
And the call out on countdown. Stage 2 LOX load is complete. All propellants are now on board the Falcon 9. We're now beginning to vent down the pressure that was in the tubing on the strongback. That's why you see the cloud coming there. The call out ground gas closeouts. That's where we bleed the pressure off. And that cold gas, when it reacts with the moist, humid air right off of the Pacific Ocean, gives you that nice white cloud, an indicator of launch coming up. Next event, T-minus 1 minute. We should hear the countdown. The Falcon 9 flight computers are in startup and controlling the rocket for the remainder of the countdown.
We're now about 30 seconds or so away from liftoff in real time. We're going to go ahead and listen into SpaceX call-outs from here on through liftoff.
Right on time. Falcon 9 flight computers on stage 1, stage 2 are running the rocket through the last minute of the count. We'll listen to the go call-outs.
LD is go for launch. Mission director is go for launch.
SpaceX and Space Force directors giving their go for launches. We're coming up on T-minus 30 seconds. All systems continue to remain go for launch of Falcon 9 and U.S. Space Force 62.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, ignition. And a liftoff of Falcon 9, go USSF 62, go SpaceX. Equals pitching downrange. Stage 1 chamber pressure nominal.
T plus 40 seconds into flight, Falcon 9 on its way
Telemetry or nominal.
with U.S. Space Force 62. Good call outs there, power and telemetry nominal. Propulsion is nominal. We're into the throttle bucket. We're throttling down the 9 Merlin engines. We prepare for the period of maximum dynamic stress coming up in about 10 seconds.
Supersonic.
Faster than a speeding bullet, we've gone supersonic.
Max-Q.
Max-Q call out. We're through the period of maximum stress on the vehicle. We have throttled the Merlin engines back up to full power. Now coming up, we're going to have 4 events. We're going to get main engine cutoff. All 9 Merlins will shut off. We'll then get stage separation, where the first stage pushes itself away from the second stage. And then the second stage engine will start a few seconds later. The Merlin vacuum engine on stage 2 will ignite, and that'll boost the payload into low Earth orbit. We will then have same time, the boost back burn start. Falcon 9's first stage is going to ignite 3 engines, orient itself, and start to head back to land on land, right back at Vandenberg next to where it lifted off. Coming up on main engine cutoff.
Stage separation confirmed.
And back ignition. Stage 1 boost back startup.
You've seen it, the first stage heading away under the power of its 3 engines. The second stage vacuum engine is lit for second stage engine start 1. A nice view there of the Vandenberg coastline. Even a little bit of the white contrail visible from where we left Earth on Slick 4 East. Now the first stage boost back continuing. That'll go for another half a minute. We're coming up on fairing deployment next.
Fairing separation confirmed.
We've got call out that the fairing has successfully separated. You're looking right now a view. The first stage continues under the power of 3 Merlin engines. It'll continue to rise towards apogee before descending back down towards the landing zone at Vandenberg. Second stage, meanwhile, in the middle of its 6-minute burn on its way into the parking orbit.
Stage 1 boost back shutdown.
All right, we've had a successful boost back burn. We've shut down the 3 engines. The stage nitrogen thrusters now beginning to reorient the first stage, and the flight computer has commanded the large titanium grid fins to slowly begin deploying now that the boost back burn is over. So right now, we've had a great launch. First stage has done its job so far. It's on the way back. Second stage is running at full power. We're getting great views from space. And we're getting ready now for first stage to come back to landing zone. Atticus, why don't you take us through the sequence of events we've got coming up?
And you heard some good call-outs along the climb up from John Insberger from SpaceX. Currently T plus 4 minutes, 30 seconds into flight on the SpaceX count as the first stage booster making its way back down for a landing. Again at landing zone 4. In just about 1 minute and 15 seconds, we'll see the start of the first stage entry burn. That burn lasting less than 20 seconds. The landing burn coming up at about T plus 7 minutes, 24 seconds into flight. Assuming a good landing today of the Falcon 9 first stage booster, this one going for its 3rd to date. This will be the 17th landing over at LZ4 and the 296th landing of a Falcon booster to date. That includes both for Falcon 9 and Falcon Heavy launches. Some great views of the Falcon 9 upper stage engine continuing a nominal burn here. Currently, the Falcon 9 first stage using its hypersonic grid fins to guide it back as it makes its way down towards LZ4. Views back now with the Falcon 9 first stage. Occasionally, you'll see little puffs in between those hypersonic grid fins. You can see them tilting now. There's the entry burn getting underway. Also, the reason you're seeing some toggling between the camera views on the upper stage, according to John Edwards, who's the vice president of Falcon launch vehicles at SpaceX, says they do that in order to, quote, keep an eye on both sides of the engine in case any issues develop in flight, such as nozzle streaking. So they're looking for hot or cold spots that are caused by what he describes as non-uniform turbine exhaust distribution. Call that Stage 1 FTS is saved. The flight termination system has now been deactivated as it's making its way back down towards Vandenberg Space Force Base. Stage is now transonic. Now below the speed of sound, you can see the speedometer dropping precipitously. Here's the start of that landing burn. Let's go ahead and listen in.
Engine has now lit. We are slowing the vehicle down very rapidly. Should be seeing those landing legs deploy any second now.
Stage 1 landing leg deploy. Stage 1 landing confirmed.
And there you have it. We have successfully made the 279th landing of an orbital class rocket.
Stage 2 FTS has safed.
Coming up next, we will have the second stage engine cutoff, or SECO-1. And following that, we will enter into just about a 40-minute coast phase as the vehicle ascends to its target orbit.
And as you saw and heard the callouts for, a good callout, good sights and sounds of the Falcon 9 first stage touching down at LZ4 for the third time following its third launch. There you see SECO-1, that MVAC shutdown. They're entering into a coast phase at this point. And fortunately, because this is not while it is a national security space launch system mission, it is an unclassified payload, which means we will actually get to continue on with the SpaceX feed on and through to the point of spacecraft separation. You can see on this telemetry map the path of the second stage following that blue line there. Popping back over to our graphics for just a moment, let you know the timing of the events here as they come about. We just passed through second stage engine cutoff, what you saw there as the Merlin vacuum engine ceased firing as it went into a coast phase. Coming up next will be the reignition of that engine for a second burn. SES-2, or second stage engine start, at T plus 49 minutes and 51 seconds. That 5-second burn will conclude, and that'll set up for the deployment of the spacecraft at T plus 54 minutes and 57 seconds. So far, all moving well on this mission here, dubbed USSF-62. If you joined us after we talked about the spacecraft itself, I want to go ahead and go back to that for a minute, since we have about, over 30 minutes before the next event here, or I guess just a little bit hair under 30 minutes before the Merlin vacuum engine reignites. This is a rendering of the spacecraft that will be deployed, the weather satellite known as the Weather System Follow-on Microwave, or WSF-M space vehicle. Built by Ball Aerospace, which is a company now owned by BAE Systems. That acquisition went through just earlier this year, as a matter of fact. Ball Aerospace was contracted by the Air Force to design and manufacture this spacecraft. Back in 2017 was when they got their first contract award for this work. They were awarded a $93.7 million firm fixed price contract back in November of 2017. About a year later, they received a $255.4 million contract modification, allowing for, quote, the option for the development and fabrication of the space vehicle itself, with the goal of having it completed in January of 2023. Spacecraft passed a critical design review in April of 2020. That's when the fabrication of the spacecraft actually began. This is all designed to replace what you see here on your screen. This is an artist rendering of the Defense Satellite Applications Program spacecraft on orbit. That's what it was originally called, the DASP, later referred to as the Defense Meteorological Satellite Program. The first one of these launched back in 1962, declassified in 1972. These satellites originally fell under the purview of the National Reconnaissance Office as part of what they called the Corona program. You can read about that more in our article currently up on spaceflightnow.com. By the early 90s, an agreement was forged between the Department of Defense, the Department of Commerce, and NASA to converge their polar orbiting weather satellite programs. And while the funding for these stayed with the Department of Defense, by June of 1998, the operational responsibility was given over to the Department of Commerce. And for those not familiar with the inner workings of U.S. government agencies, I don't blame you. NOAA, or the National Oceanic and Atmospheric Administration, falls under the Department of Commerce, and their Office of Satellite and Product Operations was the part of that agency that oversaw this program after 1998. Over the decades following that, though, there were a number of issues that cropped up, ultimately leading Congress to cancel the program in 2015, including the breakup of a few of these satellites on orbit. Those included the DMSP number F11, F13, and F19 spacecraft, all having issues. The F19, it was actually just 2 years into its planned 5-year mission when it suffered what was described as a power anomaly, which prevented controllers on the ground from being able to operate it as intended. There are currently still 3 of these spacecraft remaining on orbit. They are the F-16, F-17, and F-18 designations, launched in 2003, 2006, and 2009, respectively. The F-17 and 18 models do have an expected end-of-life date in the year 2025, coming up soon. F-16 was expected to conclude its mission in December of 2023. It's according to the Committee on Earth Observation Satellites. However, that end-of-life date was extended. Unclear exactly for how long. But the spacecraft designed to replace it are the 2 that are launching, and what we just saw, liftoff today, currently on board the Falcon 9 second stage. That is the one you see in this picture here, going through some final checkouts at Ball Aerospace's facilities in Colorado before it was shipped over to Vandenberg Space Force Base. The second space vehicle is currently in work. In November of 2022, Ball received a $78.3 million firm fixed price contract modification to begin developing that second spacecraft. According to the contract language from the Air Force, it has an expected completion date of November 15th of 2027, aiming to launch the second of these 2 space vehicles by about January of 2028. Of course, we'll see if they're able to keep that timeline. Certainly would be important for the capabilities that these are providing, since the satellites that they are going to be taking over the capabilities of and advancing them are certainly aging out, to say the least. This is an image of that first space vehicle prior to its encapsulation ahead of today's flight, which we saw a good liftoff on. Taking a look back at our live chat. Want to thank Cake Invasion for a $2 Canadian super chat. Really appreciate that, Cake. One of our channel members, SG, for a $2 super chat. Thank you so much, SG. Really appreciate that support this morning. And I want to welcome our newest channel member, Titan1, joining us at the pad leader level. Really appreciate that, Titan. Glad to have you with us. Channel membership, of course, comes with a number of perks, including discounts at our online shop, shop.spaceflightnow.com. Access to member-only videos here on YouTube. And the ability to watch all of our Cape-based launches in 4K. Coming back to this mission here. We're just a little under the 19.5-minute mark into flight from the SpaceX feed. Taking a look back at the telemetry map here. You can see the second stage still coasting over the Pacific Ocean. And actually just noticing that we're not actually seeing movement in the graphic here, although the spacecraft is very much in motion. Hopefully SpaceX will be able to resolve their telemetry map here. At this point in the flight, it actually should be well beyond this point, and hopefully we'll be able to bring you some views of what that looks like when SpaceX gets its graphic fixed. What you're seeing here on your screen are the payload fairings that encapsulated the Falcon 9 rocket's payload on the USSF-62 mission. That being the weather system follow-on microwave satellite, of course. Noteworthy here in that this was the first time on a national security space launch mission that SpaceX used flight-proven fairings. This was their second time going out for a mission, having previously flown on the USSF-52 mission back in December. Fairing use is something that has been looked at for a number of years now, and something that the Space Force, Space Systems Command, and SpaceX have been talking about and working towards. And it's important for all involved that they're able to refly fairing halves, as is the case with most other SpaceX flights, as it does save SpaceX about $6 million, according to the company. And that cost savings would, of course, be expected to translate into savings for the government and thereby the U.S. taxpayer in bringing down the cost of these missions. To date, NASA has not used reflown fairing halves, but being that they are a close partner with SpaceX, they will likely be looking at the data gathered from this mission and factor that into their assessment of the point at which they feel comfortable using flight-proven fairings. It's not just dependent on the number of times a fairing or a booster half is flown, but also the conditions under which it launched, the stress it was put under, the landing, the recovery. All these factors go into the reuse equation, as we've been told by Dr. Walt Lauderdale. As a matter of fact, if you are one of our channel members, you can head over to our member videos. We have a full conversation with Dr. Walt Lauderdale ahead of the launch of the X-37B space plane that lifted off from here at Launch Complex 39A aboard a Falcon Heavy rocket. We talked about the path to reuse during that conversation, and it's a good way to get read up on or get some insight into what they've been looking for and studying this issue. Again, that full conversation with Dr. Walt Lauderdale available up on our channel for our member community. We're now T plus 26 minutes, 40 seconds into flight in real time. Our editor, Stephen Young, back with us behind the scenes. Appreciate Stephen being with us again this morning. At this point in the timeline, we are just a little over 20 minutes, about 22 minutes away from the second stage engine's second burn. That 5-second burn will set up the conditions for payload deployment that's coming up at T plus 54 minutes, 57 seconds. Taking a look here inside Mission Control at the SpaceX headquarters in Hawthorne, California. Presumably they're working on that telemetry map graphic, and hopefully that'll be restored soon, so we will either get some onboard views from the Falcon 9 upper stage, or at least a good telemetry map. SpaceX busy, of course, on a number of missions. Not only the one they have in work right now, but as we learned from the company just about a week or so ago, they're heading into thermal vacuum testing for the SpaceX Crew Dragon, dubbed Resilience, which previously flew the Inspiration 4 crew, getting ready to fly the Polaris Dawn mission, the first mission in the Polaris program headed up by Jared Isaacman, also the commander of Inspiration 4. It's having to go through a number of upgrades and additional checkouts and testing since Dragon is preparing to execute some feats that it wasn't originally designed to do, and that is to support the first commercial spacewalk. The company says they are targeting, quote, early summer for that mission. We'll have to wait and see exactly what early summer ends up being. Also worth noting, since, of course, we have a number of folks joining us from around the world, this is not our only launch today. Earlier this morning, Roscosmos, on their third attempt, was finally able to launch their Angara A5 rocket from the Vostochny Cosmodrome. So congratulations to Roscosmos for finally being able to launch that vehicle. Now a little over 30 minutes into flight. Again, the second stage engine burn will come up at T plus 49 minutes, 51 seconds for a 5-second burn. Following the deployment of the spacecraft, there will be a third burn of the second stage engine designed to deorbit it and eliminate the risk for space debris on this flight. We're now T plus 37 minutes, 9 seconds and counting. Just a little more than 10 minutes away from the point of SpaceX igniting the second stage Merlin vacuum engine again for a 5-second burn. That'll set it up for spacecraft deployment. T plus 54 minutes, 57 seconds. We're now T plus 40 minutes, 58 seconds and counting. Just about 9 minutes away from that engine burn on the second stage. So far, all appears nominal with this flight. Just taking a look around the room, and it appears in the front row there, second from the left, is Bill Gerstenmaier. After departing NASA, the long career there, is currently the Vice President of Build and Flight Reliability at SpaceX. Occasionally we'll hear his insight on briefings ahead of NASA and SpaceX partner missions.
Force 62 mission. We're just past T plus 48 minutes and 12 seconds. We're currently awaiting the relight of our second stage MVAC engine. That's coming up in just about 90 seconds from now. Now this burn, called SES2, or second stage engine start 2, will last for just over 6 seconds. Now while we're waiting to come into coverage range of our African Indian Ocean ground stations, let's recap what we've had so far today. And it's been a successful mission so far. Falcon 9 successfully lifted off from Slick 4 East at 7:25 a.m., carrying the WSF microwave payload. Stage separation occurred just before 2.5 minutes into flight, right on time. That was followed by a successful landing of Falcon 9's first stage at landing zone 4, or what we call a land-on-land landing. At about T plus 8 minutes, we had successful second stage engine cutoff, and that was SECO 1. We had the go to orbit call out just as we were going off of the air for the coast period, and now we're coming up in just about half a minute on second stage engine start number 2, and then we'll wait to hear the GNC engineer confirm the orbit. On the bottom right, take a look at the meters that we've got. You can see when we left, we were at perigee. We've now gone halfway around the Earth. We're at apogee. We're going to light the engine, and you'll see the velocity increase to circularize the orbit.
MVAC ignition.
We've got ignition of the second stage engine. This is about a 6-second burn.
Nominal orbit.
All right, we've had the cutoff of the second stage engine, SECO 2, and the important part, the guidance nav and control officer has just confirmed that we have a good orbit. So this is the orbit that we need to be in for deploying the spacecraft. So we're now going to wait about a 5-minute period for deploy of the WSF-M satellite from Falcon 9's second stage. And that's going to be just under 5 minutes from now, as I mentioned. We do this 5-minute wait because we want to make sure the second stage is quiet. We purge all the excess gases out of the engine. We monitor the engine. And then right before the spacecraft separates, we want to make sure we're not venting any liquid oxygen out of the tank. We want the second stage quiet and stable in what we call an idle state so that the spacecraft can separate without any disturbances. But we've got 5 minutes or so to wait, and so until then, let's toss it back to Atticus to learn more about today's mission.
Thank you, John. Space Systems Command is the U.S. Space Force's field command responsible for acquiring, developing, and delivering resilient capabilities and groundbreaking technologies to protect our nation's strategic advantage in and from space. Space-Based Environmental Monitoring's SBEM mission is to deliver environmental and tactical intelligence to provide an operational advantage. SBEM space programs work in cooperation with both civil and international partners, and today's payload, known formally as WSF-M SV-1, or the Weather System Follow-On Microwave Space Vehicle 1, provides modernized space-based microwave imaging capabilities for low Earth orbit weather data collection.
And you just saw for a brief second that spacecraft that'll be deployed in the next couple of minutes here. Payload deployment expected at T plus 54 minutes, 57 seconds. As you heard and saw, oh, there's another glimpse of the spacecraft there. It'll be heading up into a sun-synchronous polar orbit. Part of the reason why it's launching from Vandenberg Space Force Base. It's reaching those polar orbits a little bit easier from that part of the country. As previously mentioned, this is the first of 2 satellites that Ball Aerospace, now a company owned by BAE Systems, will manufacture on behalf of now Space Systems Command. The second set to launch about 2028. We're just a little under 2 minutes away from spacecraft deployment. Coming up now, less than a minute from spacecraft deployment. Let's go ahead and listen back into John Innsberger.
The payload attach fitting camera looking forward. You can see part of the WSF-M satellite as we get ready to deploy it in about 16 seconds from now.
Payload deploy confirmed.
All right. Look at it go. Right on time, right into the orbit we needed to get it to. And so WSF-M on its way to begin gathering that data, turn into a useful product for the warfighter. Nice views looking at second stage camera. So Atticus, it's been a great day so far. In fact, all we've got left is the sign-off. So why don't you take it away from there?
And as we heard and saw, a good deployment of the WSF-M spacecraft payload heading off into its orbit. And with a successful deployment, we'll go ahead and hang with these pictures until spacecraft's just peeking out of frame there. Let's go ahead and close out, as we always do, with our mission stats. Let you know where things have landed now that we have a good liftoff, landing, and spacecraft deployment today. Alrighty, so this was the third flight of Falcon 9 booster 1082 in the SpaceX fleet, having previously launched 2 Starlink missions and now its first national security payload. This was SpaceX's 322nd Falcon 9 launch to date, the 37th Falcon 9 launch of 2024, the 37th orbital launch of the year so far. This was SpaceX's 110th orbital launch in the last 365 days. The 73rd orbital launch for SpaceX from Slick 4 East, and the 141st overall orbital launch from this pad, the 13th from Vandenberg in 2024. Moving on to some recovery stats, this was the 17th landing over at LZ4, landing zone 4. Also, of course, the 17th landing in California. This was SpaceX's 67th land landing between California and Florida, and the 296th Falcon booster landing to date. Finally, coming out for some industry stats, this was the 13th orbital launch from California, of course, the 40th from U.S. soil, This is the 43rd from a U.S. rocket company, getting close to that next rocket lab mission heading up from New Zealand, which will add to that number. This was the 71st orbital launch from around the world. Moving out to the pie chart version of that, you can see here you've got Russia now bumping up to 6 with the launch of the Ankara A5 rocket that happened early this morning as well. And that'll just about do it for us here today. Really appreciate you taking some time to catch this live launch coverage this afternoon with us. Want to thank our wonderful channel member community and, of course, all of the moderators helping us out in the live chat as well. Happen to keep things kosher for everyone. Our thanks to our editor, Stephen Young, who's been able to pop in and assist with the coverage today as well. Most importantly, I want to thank you for taking part of your day to catch this mission, space launch for the National Security Space Launch Program. The weather system follow-on microwave satellite, the first of 2, now well on its way. For all of us here at Spaceflight Now, want to thank you for your ongoing support. Be good to yourselves, be good to others. Don't forget, we have our live News from the Press site show rounding up the week that was in space news. That's coming up tomorrow at 4 p.m. Eastern. 2000 UTC. Hope to see you then. And until then, have a good one. Bye-bye.